No.
You want to
It's not
record?
clear. Am I showing you this?
Because this is concrete. This is concrete. This is concrete. Okay. That line that you show that is going up, you need to trim it up. Because it's the same material. Let me do a different material. You can allow. This line is showing edge of something. It's not actually, the line is an outline. Like I explained, it's an outline showing the edge, corners, hidden details. That's what the line is showing. So if you show one line crossing the other, and then the same material, then something is wrong with the material. Once they are the same material, except whatever you are representing, maybe this one, I don't know, depending on the view that we're trying to present, except you are saying that you can see this line from there, you can see this line going up from the elevation. And even this one still needs to be identity. Okay? So it's even better, take this guy up, and then you trim this off. And then you make this identity.
Sir, just a quick question.
Look
Concerning
at
this,
this identity. Trim this, make this identity. Huh?
this section, you know, it's cutting across the beam.
Yeah.
So, the question is that we are trying to ask that, is that why we can
You can see this
the
beam.
beam? Yes.
Yeah. Normally, if you had moved this section away from the beam, you won't see this guy.
Yes.
So you will see this beam. It's supposed to be clean.
No. Oh, yes, there is.
So you need to put something like this here. But there's a big way. Have you? The elevation. Yeah, there's a beam there. This beam. I'm not, this is not safe. This is actually elevation. So when you are cutting the elevation and you are doing the elevation for, you should be able to imagine what is ahead or what you, the details that you need to show. Okay? So, should we
that one they just did formal for, yes, but that
Well,
one.
you show this is the extent. Can you extend this line? Draw a connection line here. Trace this line like this. Listen, trace it down.
That week. Yeah, so let me.
You can do it.
Yeah.
Once I confirm from them.
Yeah, yes. It's good. Is this thing aligned? Is it aligned? Is this elevation aligning it? It's not. When you trace this line, up now, this line is this line. This guy is this guy. This guy is this guy.
Let me see.
And remove it.
No, it's supposed to be like that. You're supposed to.
And so, you need to move the pin. Okay, so this one is extend this there. So you need to show this guy. And then mind this guy is higher than this guy. Let me see your story.
You cancelled it that day.
What are you 5 minutes left.
Hey, well, I was thinking that I didn't see this one to shy. I know nothing about that. What is your... Thank you. Thank you. Sorry. Shy.
Seven views. Seven people watching.
Watching you. Can they hear what you're saying? Oh,
Oh, for the long days.
who was it? Strangers or
Stranger. Is it I have like proper channel, right?
that's the channel that wants you to like I opened it, I opened it again. I found it for once.
I'm posting videos.
Well, I don't have that kind of time. I get overstimulated. So all I'm doing is one. I don't want to keep that down.
You won't think about
And
content.
editing again.
Don't think about content like that. There's no always department.
Oh, okay.
I know what if think about like if you're actually interested about progress and I would use if I'm not interested. Not saying I can wake up tomorrow and get interested, but today I'm not interested. At least I'm ready to try whenever I'm ready.
What review, like, do you compare videos, like,
That's what I would say interested. I'm feeling like I if you have cherry, I got the animal that we used to advertise that once you move, looks like this. I don't know if you know it. The tripod is like this. You can put it here. It's the camera tripod. Then also for the first time. And also the camera I forgot it. Yeah. So you can do like this. Your phone is so it's very. I even got. I also got normal tripods. No cases like. Nothing. At least I have them for the start.
Yes.
So if I wake up one day, I have wait. I have.
All the big one.
So I have. So if there's a change in level.
That's
He said, the way he said it is that there's supposed to be like, it's supposed to be dark
No, they are
now.
not saying that. Why is our own work you do?
All the slants like this. I'm trying to remember.
That's what they are saying now.
So this is from grade F to grade
150.
F.
They are trying to say that the architectural requirement
J.
is
There's a
150.
change in. There's a change in.
Yes. So I don't know why we should be the government to me.
See, like, on
You just seeing this model. What look
I
at
don't even know how to
why is your
I know how
finance
to do
taking
it
on
like
their
by drawing. It's supposed to be like this. Let's say this is.
You want them to be
It's
so
supposed to
nice.
be- it's supposed to
You
be
don't
like this.
continue with the hype for the rest of the world.
You understand? You got to say that. You understand? So I don't know.
How? And more the space.
That's
What
what
is the sense of sending you model? Gbogbo nǹkan tá kọ́bí ìlú model ni. Then one point house again. I understand. Tó bá jẹ́ pé your model was clear àbí you had issue with this. All you are asking am make different for alẹ́ ìgbé wọn jáde àtẹ̀ṣe. Nígbà yìí you no pọ̀ yẹ. And you can be calling for your phone that they let you go more 150 because there's no need for us to complete for us. Wọ́n ti ṣe eré oṣù fún ọmọ ọlọ́run ló ní kúrò lédè ní. Yes. You should look at the model now. That's one can say, oh.
How is it going?
Yes, yeah. Yes.
So, where are we? Oh, we are arguing about something.
Change it.
Are we guys saying
Yes.
Yes.
none of it captured this?
We.
None of you captured
I actually.
Is it not there?
It's there, but
How do I just
You were using
about
to
it?
explain. I actually thought you did it. I didn't see it.
Yes.
So you didn't,
And
you
I'm
didn't
so
see.
sorry,
I
what
didn't
this
see
one
it.
does only
So you didn't capture it.
you know, this is not
I
that
didn't
that
capture it.
needs to start from
Was
the
it
first thing that
Yes.
the crack must see.
Okay. So what else?
The diagonal, yeah, the diagonal, that's what I'm saying. They need to, you know, where the straight vertical and horizontal meet.
Why would
The
the
diagonal is supposed to
in
be
the section that
you see.
you see?
And yes,
six
the
lines
one
there,
on the
which
right
is
was
what?
one in front of it before. and I
So
took
why
the
do you have-
just on that side? No, I don't know.
Why are you using this?
And then I took the carrying now. You know that one
Am I
that
doing
is
this?
that is carrying.
Dimension star.
That one beside what
So they measure the dimension is flat thickness.
I dimension the slab thickness.
Then put the level marker. Where is the flat thickness? Is it the same thing throughout?
No, it's not the same.
And why is your
Yeah,
why do you have
I-
7 decimal places? Is that not seven?
Yeah.
Yes, I know.
Why?
I know.
Yes.
I wanted dimension to be
Accurate.
kind
So
of.
we can see, you think they will measure 0.5 or something?
Yes. Okay. Please.
Or you think they will 0.00001?
The first model we designed. Now your specific architectural
All you need-
should be clear.
You need to, you are trying to teach you, it's not about,
Yeah, that's what
you have to teach you how to be smart.
I'm using the instruction to back it up.
In the environment
Thank
that
God that
you have dimension
God
star.
has make you guys to be great.
It's like this one, dimension star is this one.
If they had told us this information, what we would have done is just terminate the basement course and bring money back out and do their 150 for them. A block walk, yes,
It's
exactly.
layer for
So
dimension.
what I want to ask them now is, are they okay
Use
with block walk?
section
So that we just turn that place off.
Eh?
I was not that close to this line. I was like,
Because what I'm saying, we only leave, but we will not probably.
Dimension star standard. So if you select this, change it to 35. Is this not better than what you had?
Yeah, that's what I want to say. You can leave the iron, but you
I
have
cannot
to
see
leave
it.
the block off.
Why? Because you don't know how to use AutoCAD.
Yeah.
no,
but
like
this
I
has
want
to
to
be
see
very,
it
very
immediately I
straight.
open the.
You have light problem.
You get because 150 is too
No,
tiny.
no, not
If you
really.
zoom, you want to see it.
That's the problem. I don't want to zoom into my see. I wanted to see it without zooming.
So does it not make sense?
No.
What's the difference between this guy and this guy? And if you insist that you want to use this text,
No, I don't exist.
you insist that you want to use this font. Select, just scroll down. Leave it at 630. Or there is even 60. You can increase the 6 less 50. You can create your own.
Okay.
Right? Select 60. Then scroll down. Go to text property. Text, under text. You can change the text color, you can change the text type. Text size is 4. You can reduce this. 3.5 or 7 if you would like. You can put it 10. I don't think it will be effective. Select person. So there are some that will not change. You have to go into the before. Even if you change it, it won't affect. You have to go into the dimension star and change it because they are new to the style of the dimension. So now there's delete this. Delete this guy. You can see we have 690 everything. It's not other than 690.5. So if you want to dimension, it has to be on the same line. Let's say this is a major grid line. That's the primary grid line. Let's say you have a secondary grid line in the middle. So if first go to dimension from primary to primary, and you now do second line of dimension from here to here, from here to here. Okay? So now, if you want to continue this dimension, just it needs to be on the same line. But so that you don't shortcut for dimension is what? DIM. So that you don't start looking for the center point of this one. Those type dimension, those dimension continue. So type this here. To tell you, is that this is not. Only is wrong with the program. So you tell you to select, you can actually go to continue. You select it, and then you continue. So then you select. If you have another one, keep selecting. So it keeps that straight line for you. So your guy came here with these two big guys. Look at the guys. And came out with this one. And came out with this one.
Finding my section page. I used to go to Europe because I have to teach rubbish there. Why is this not Europe? This is Europe. Wrong.
Yes. Okay, you said, okay, yes, I've seen it. Yes, I've seen it. Have you guys put it everywhere? You have to send me another form now that shows the area you are casting. Even though I've checked the others, yes.
Why do I just use this one?
Yes, exactly. Have you guys going to put this one in? Yeah. Please, all these feedbacks, if you look at them, they are not, they are scattered. You have to tie them to the proper place they need to be tied. Like the way I said, you know the slab that is returning into the beam. Don't let them be dancing around. The neck, overflow, yes. You know that's the river that is going into the beam. You guys need to go. Yeah. Okay, show me something.
So, Waga. So, I've called the
You don't know them, you have to do it.
That's why I'm very low for that because the size. So, yeah. So you understand? So you need to move the dimension like before. So that it's close to, it's too close to this guy. And then it's big. It's bigger than, you can see what dimension is taking. And out of the entire, by the time you put this on sheet, this looks, oh God, it's jumping out. That's how you have to draw to scale. Looking at the proportionality of this to this doesn't justify proportionality. So that's why you need to, it's not about what you can see. If you need to see, you zoom in. But you also need to draw, you need to draw to scale and proportionality. So, oil. Select the white line. Look property. You can't go to property first. So why are you using the zero? Then you use green. Let me see, why did you use green? Okay, even the layer is correct. The whole layer is not correct. At least this is GA section. You can choose any color that works. You have to use the color that works because every company has a stamp. If you choose to make green your letter works. Like I told you the last time. No dimension, no dimension. This is of the dimension line needs to stop. If you notice, there's a gap by default in your settings. There's a gap between the tip of the dimension and where the dimension line starts. You can adjust it. But this is not done. Because you could have as well, you won't know the extent of, if you are not dimension, you won't know the extent of where the pin is starting. Like how you print, you won't see where the pin is. Everything is black. Alright, so you need to put section marker to indicate sections and the levels, level marker to indicate levels like to plan. And so they can know, okay. And then, okay, if I just take this guy away, and like I told you, yeah, some people do the dimension like that, and that, 5 off. And then dimension from grid to grid. Forget all this. You only do this with only and only if your beam is wider than the normal size to show it. So there's no point. Are you sure this green line is you need to? This is not the one you need.
This one, yeah, this one.
This one. You have to green lines. Why do you have to green lines? So, what do you have to? This is on this one. Let's see, we have to select it. Okay, so that's B. So your B is the one you just deleted. So this one actually just B is off B. So go back. So if you are thinking you want to reference the primary, that's what I was talking about. You want to reference the primary line, which is B. Where is it?
Yeah.
This is it, which is B. This is your B. And the center line of this graph is not B. You understand? So you need to, what we do most times,
this thing feels like I want to kill it. I want to use this to pick this is Alaba. What we call Alaba in your business. So what we do one day, I can tell you one day. This is use this point to enable this to skin. So I don't use that box to trim the payment. It's not like you get anything. Explode the wheel light. You explode the wheel light. Why? Now you're gonna play with it. You have to be.
We wanted to delete something that they were not deleting, so we had to explain.
This is doing, it's not doing anything, so you delete it. This is still too long. But by the time you are putting another section, another section here, you have to put it after this green line. But if pen on your paper space, this will just be vacant, nothing there. So what we do is stretch this guy out. You need to find a way to centralize this guy. Centralize this guy, right? Yeah? So like I told you, you can copy this guy, to F5,
Yes.
and then what's the last one? J. When we are doing it, we still need to do all these nonsense. But it's good to know. You can copy this guy out. Is it J? Make sure it's J. No. It's not. So just F and B. C. J is part of it too. There's only F that aligns. Read? So so you can see. So because this one is in the center.
ọkọ ni mo fi máa ń pè yìí lọ́jọ́ tí mo rántí ilẹ̀ ti ṣú mo ní àwọn àti sùn báyìí ooo iṣẹ́ ó lè ooo ẹ̀yin kọ́ báwo lè ṣe ọ̀ṣẹ́ ẹ̀sùn ti kùnà lọ ṣé madam ti strong dáadáa ṣá ṣọ́ ti fi yílẹ̀ so where are you going back to Delta for that one?
So because this actually has no business, so we can move it up. Okay? And because it's your primary green line, you can stretch it up.
Okay, so you are already on the way.
So same thing with
Okay. See,
the BRW business. We can come back just for the difference. Move it right there. So
Save journey. We are the one that is 1 hour. Okay.
why is this stop? Things like touch. So now dimension. So this is also one dimension. You understand? Really know your dimension. So whoever, because on site they must have marked out for agreement. So they, but they know that center of this beam is an offset from this line. So when you're doing the form and you're looking at the section, you know from this section this line and this line are the same. You understand? So this is how we present strain. The cantilever, slab thickness, slab depth, beam depth, and then the level marker. Hmm? You guys want to give another try?
Let's go to see.
That'd be the first question.
What question do you have?
Did you just say?
What is this one? What is this one? Section C. Why is it showing? How do I do it? Now, I forgot to tell you guys. This is your height. These two guys. Okay? It's like you stand here, like cut this. Let's say this section, let's say, cut this tube. Not this, you're not looking like it in this direction.
Sorry, what was it?
You have this section.
Yeah.
You're like height. You're looking upward. That's what it means. You're looking upward. So when you're showing from left to right. So you're looking upward. But this gap is different. Because you are looking like this. So if you are looking like this, and you want to turn it. Because if you are presenting this section, you know, some people present it like this. But if you want to present it properly, those two.
You have to rotate it.
You have to rotate. So it's like in your mind, you are rotating.
That particular section.
Yeah. So if you were to be facing down, if this section were to be facing down, because we don't actually structure when architect cuts the section facing down, and then you face like the right. You face this, you face right. You understand? You also change when you want to shoot. So there's no stand when you're cutting section. Cutting to another section, you cut. Cutting this one. Alright, so what is supposed to do? So with this, can you so this is totally wrong. If this is C, this is totally wrong. Because this level and this level is the same. So why and this level is the same? So why shouldn't you mistake that? Okay. Are these? Yeah, why is this showing? Is this broken? Anyway, there's no void there. That's what I said. If this is continuous, this is slab here. If this section account to be passing here, you have a void here from here to here, and you have another continuous slab here. So you're not even showing this view. You're not showing this view. You're not showing this view. Let me see the one. Section C. How do I want to do it?
Sir, my own logic of this thing was the depth is the beam, why the length will be the column.
Let me see. The length will be the column.
That
What you
was
said does not make any sense.
that.
The length is what? It doesn't make any sense to me. It might
Let me show you.
make sense to you. No, let's look at the
This
plan.
is what I'm talking about. Like if I'm saying it from this side, like this is how my own logic is.
Okay.
That the depth is the beam, then this place, the width is the column. Like we're going to use the column instead of the beam width.
Your beam is a rectangular section. You have to do a rectangle. If you have a 20 by 450, the width of the beam is 230. The depth of this is 450. Is it different from what you're talking about?
It's not different, but my Sir, don't worry. I already understand what you are
And
doing.
let's look at the section C. You're not showing any continuity. She showed a broken line, and slab is not continuous. What you have done here is not. Go back.
My only lines are
So it's not correct. So you want to go and correct it. Because all this section stops inside this line. You have to show it as broken line. It doesn't stop at the discontinued edge. It stops inside this lab. So this lab, even though the section stops here, this lab is still continuing. So you have to show it in the way that this lab continues with a broken line or with a break line. Right? You understand? This is a finished, it's a discontinued edge. So you don't need to put a break line. When you have continuity, you need to put a break line. Okay? So what else? What else do we have? Any other question?
Yeah, I have a question. So the other day you explained this
Yes.
before you went, so you're talking about this area is higher than
and I treat it like a huge.
Okay.
Yes.
Yeah.
so can you
So we are trying to like put it on the system.
So what I was trying to say, there are two ways to represent. There are many ways to represent the bed. One of them is with a dropping the slab level and put a pin to show that drop. Like what I'm saying is that this is step down. Okay. This can be a pin. This line, I can make it a pin. So this is what I will have. I know this is my series. Which I'm not supposed to. Don't worry, I'll make this one.
So everything is related to what I'm doing.
I'll be that. I'll be that.
I cannot.
I'll be like, so, that's what I'm saying. I have a problem with that. Okay? So I can choose to make this again. This is a transfer. This is a blue. This slab is continuous. Okay? So if I make the join the section allows, the plan allows, just to make this the proper head to the drop down. Or I can do that. Let's put my slide there. But in this situation, there's always an issue because of the verticality of this section. Sure. So, two ways. Either you make this dimension as in this way, either make it very wide. Let's see. You know, we can see it. Let's see. So if that easily what are we going to do? Can you count your fire? And this is wide enough. Okay? And it doesn't have a shear problem. Let's assume it's not like this. And this is solid.
Yes.
So if it's wide enough, this is wide. Easily come down. Or now, because coming down is how it should. Getting this so to save everybody's stress. I choose to do this. under the slab, which is this. So we have this. So we don't see not many, because by the time you check the thickness of this guy, it will be as thick as 150 the thickness of the slab. So it's strong enough to transfer the stress. So because of this thickness, you don't have any shape of so if you want to go with this guy, you need to make this guy very thick. This joint. You make it very thick. Okay? If you want to go with this, go with this. And if your skin and house, you can introduce it in this guy. You understand? Any other question? Are you guys? Why not? I should left it. He's gone. Alright, so look at it.
So another question. For this section, that we're doing, what are we considering? So they depend on considering. Like,
Why are you not considering the colors? That's what you're saying.
yes.
And what you're doing slabs, the first section. You don't need to show colors.
So what did you call it?
No, first slab, first section.
Okay.
And even it's a flat slab,
Oh,
which is supported primarily by. What I want to show you that I want to show this element, and I want to show what is supporting this. You understand? I want to show this slab, and what's supporting this slab. Waves. So if you have a flat slab, I want to show.
full on one that.
So once you guys get this, I'll take you a little further into what's it called? Wave slab. Sorry, slab. Sorry, same slab. When you see a big slab, I will guide you. So then I will explain to you because it's more complicated than it. Because you have floors, you have beams, which are the ribs, and then you have pots inside the ribs, and you need to shoot. So by the time you go into that, what I was saying about the elevation thing will be more illuminated because then you need to see the clay.
You want that place to be rigid because
If you're cutting the section, you need to shoot. But this is just basic. By the time you are in most of it, you don't need to think about it.
you know the height is what height
It's
is
good to know.
the problem with money. You know it's only be straight or you want to follow the slope.
Any other question?
Let it be straight.
So what does this line mean?
It's can you also look at any other because I know that this is an
Yes.
because of your
Exactly like this. Look at the architecture plan. Let's look at the architecture. Now I told you guys to look at the architecture as well. Right? It's not in doubt. It's in the exercise.
I just want to share my.
Look at the first one. Zoom in. So it's there. So let's go and see what it is. Select the elevation. Let's go to the elevation. Elevation is also. You can see. It's those guys.
These guys.
Yeah. So in hindsight now, select it. Raw material. So he said it's a wall. Abi?
Yes.
So the wall needs to sit on something. Abi? That's why we extended our slab. Okay? So you need to look at all these details when you are doing your skin so you don't miss out anything. imagine putting that out of sight. How are you going to do it? Okay? Alright. Any other question?
No, sorry.
No.
Yeah, so what happens is, okay, I said it's going to count, any space in that work. That's why it's so
So I still have a question.
Go ahead.
I still need like a more clarification about this A section.
because if you do block four,
So if I move the section of what it is, no, I'm going to problem.
No, I don't want you to move it. I want to understand the concept. I already understand the concept, but I'm trying to like pin it.
So what do you mean to understand?
Okay. So you said the section is over the bin. Through the bin. So how we like cutting it? Like okay, that's what she did. Okay, just like that. Do you understand what I'm saying? So the second question is the change in level. Like you already explained how we can design it, but how do we use the dimension for that set? I don't know if you get what I'm saying. You know the change in level is 500.
300. 150.
Oh sorry, 150.
Yeah.
So are we going to increase it by 150?
The only thing you have to do is in case of the formula, which you are going to
Your view.
and cut one of the issues to the first and then
I want to do the lazy way. What I would do, the lazy way. Let's say
one single
Well,
one,
yes,
yes, exactly. Yes.
and they actually just wake up and say, the other woke up and said, this is supposed to be higher than this.
Yes, and you guys can do because I does not check.
They all them
I just go to
mass concrete.
Yeah,
Let's say this is not going to be at every load.
that will not give us
If I
problems.
check and if they use mass concrete, it's not going to affect because they've already done this on site. Instead of just use mass concrete.
If you require instruction for it, just leave it outside because we have to do it. You understand?
We just
So what makes it concrete mass concrete?
More.
Mass.
Like more like
we're considering sequence, right?
Mass concrete, plain concrete.
clean.
Unreinforced.
Oh, okay, yes.
You don't tell them to pour one
Yes.
and then pour concrete.
Okay.
But it's not going to be very lean concrete, not very dense. So they can achieve this level. Okay. But now let's say this is not an afterthought. Okay. And it's more expansive than it's bigger. You cannot tell them to use because even if it's not an afterthought, let's say just this side. I mean the length of the upstand to the level just from here to here. I can still do the mass concrete. So I don't put that very down to the levels. So that is slab, then the mass concrete.
Okay. So the slab will be the same level then. They are going to do mass concrete, that's small.
Yes.
As against lean concrete, what we can also do is to fill walls or polystyrene or clay, broken clay, or even broken tiles. Just fill it and then put more lines and then tile the lines together. Get it? Now, what can you do? What can you do? This one is 450. By the time you get here, because you are increasing up 150, from here to this being becomes because you are increasing up. If you are not doing mass conflict, this being have to become 600. Now I know why engineers are different. Engineers are different.
No.
Maybe this TV is interactive, that's kept on. You wanted an interactive TV, it was very expensive for people. But why?
Is this fine?
Okay. So
How am I going back so that they must say the person
they wanted an interactive TV.
Okay.
That would have made a lot of sense now. I explained this to them, but it was too expensive for me. But we'll still get it by the grace of God. So,
Okay, you want to
then this sketch and
it told you what you soon here. Maybe he would have done anyway. I'm a comprehensive boardroom. Then we can go there and explain.
This bill is 415. This is 415. That may take the conversation there. Because around 15 minutes. That's what I'm saying. So, one to this bill comes up, and then it goes back to 415 and continues. The best thing for association wise for you to have, you don't want to have, normally, this is what you might have just talked about. This is what you can come up to and then go back. And this is what you guys should probably do. This is 450, another way.
So you'll be here first thing.
And three, you want to become more concise. You have to first do this one. Then you do this word. And then put up four. It doesn't make sense. It does best to continue it. So most times, and also that allows you to go down, to go straight. It's against this alignment. You understand? So most times when you have things, either depending on the structure, this end, how you keep your top, this end out, and then the bottom. So this is 600. This can be whatever you want to do. Okay. So far as connecting this system out together, this system out together. For construction work, I'm making 600 as well. So if this can work as 300, this becomes 450. Is that it, right? Yes. Hello, Gabby. How you doing? Hello, sir. How are you, sir? You use your two legs to come here. And you now pick 1,000 as smaller than what you come here. Why? It's too small. But it's smaller now. If Dangote give you job, that's what you go do am. So you can't this side in the market again. Okay, that is one. Number two, this my door. Why do you want to put blue there? Why do you want to put blue here? But your guy wants to put blue there. Your guy wants to put color blue tiles there. Blue tile. But it doesn't have that color now. You need to go. All the bottom was, it's blue, right? So, another question.
No question.
So, you go and do it again, right?
Yes.
No.
See, next week Wednesday.
No. Today is just Wednesday. I'm coming
I'm
on
asking
Friday.
you.
No, I'm coming on Friday. In the morning.
No, I know you have to say, okay, are you going for your party? You're going to
I'm not going again.
Okay, so you are coming here tonight.
Priscilla said she's not going, so I'm not going. The lady that came yesterday, the other day.
Okay. So, she will be here tomorrow. We want her to wait for you till Friday. So I can explain the both of you.
Yes.
Yes.
Sorry, not okay.
The staircase, abi?
Yes.
And you can listen in. Okay, what you need to do all the time. Let's look at it. So, now, suspecting that.
Yes, that one is I was thinking about.
Why do you think it is?
Because they mentioned that this is the first flight. When I read more about it, they said this is the first flight landing, then this is the second flight landing.
This is half landing. It connects those flights. So it doesn't belong to one flight.
Yes.
Yeah, so what do you think is wrong? Why do you think it is wrong? Can you design it? Okay. Can you design anything? Slap.
You want some funny thing, but
You can copy like
So I don't copy book. If I want to copy book, I'll copy this thing.
that's what you see.
It's because like I try to understand the logic. That's why I should not like I keep going
So sometimes you don't use this for fun. In the countries, sometimes this is more than 1.5. Sometimes you can have one, for example, now, open that for me.
But is it the staircase? Where is the staircase? For the first floor.
That's the difference. So this one, this is 3.5. So this final line is 3.5. So are you going to use 3.5
It's
plus?
too much.
So what will you use? So there's a specific provision in the code. Give me the code. Give me the
I'm
code.
good. Asking me.
You didn't give
He
it to
didn't
me.
reply, but I asked him again today so that she reminded me again.
Where did you get the code? There's actually a function in the code that tells you what the maximum width you can consider for your land, which is more than a certain limit. You can't imagine it in the code. So let's go back.
Yes, how can you imagine here? Ọmọ àti ẹ̀sìn wá ní wá lójú ẹ̀, èmi ló ń pressure pé why is it like this? Why is it? O sọ pé àbí get produce like still be supposed to compress it for wá do as client
And
wá
we move to thickness of the
this
tool.
thing what's happened today.
And two, but this is not what is 55.
You're funny. Is that why they were
When I did 2000.
Measure
No, when I did 2000 minus 65, that's like 117.
it's about close to 1.8.
Yes.
So take it like that. So 9 times, so M is 0.1, use the formula.
Yes.
The formula
0.1 WL squared.
What's when you get this 0.1? You get this 0.1.
3.966.
WL squared. Is 0.1 WL squared?
No, it's WL squared. This is where the this is the 0.01 to 0.125.
Yeah, I'll be the one who step and says, also price pound to 2 pips. When it is found into So you know what's one W square? Your head is
Yes.
newtons. So let's go back to this guy. Your new estimation.
This is in 74.
Yeah, so you understand how it goes.
Yes, they use riser.
That's what they just make us saying.
Yeah, they use.
The waist, uniform waist of 150.
Okay.
Took the uniform waist of 150. Go back to the section.
The sectioning is actually for.
Yes, it's still this one.
Okay.
So this waist is thickness of the slab, the structural thickness of the slab. It doesn't consider this triangular thing.
Okay.
This triangular thing is mass concrete. Except you have stepped, what do you call it, scissor staircase that is going like this. The zigzag scissor staircase. Because the underneath it's not straight. This
Yes,
is scissor
it's
staircase.
not
You know the staircase is like this.
Yes.
But if you have something like this,
Equal riser.
then you have this. This guy is what you are designing for, not this guy.
Okay.
This guy, they are mass concrete. They are just weight. They are just weight on your staircase. This is the structural.
Okay.
Alright. So that's why you picked. Let's go back.
3.15.
That's why the concrete own weight is 150 times.
24.
150 is the waist. 4.15 times 24 gives you 3.6. Okay?
Yes.
Alright. Now your step, which is triangular. These are your steps. This is 250, abi?
Yes.
This is what?
175. No, 150. Sorry, this one is 150.
Okay? So that's the area of the rectangle is what? The area of the triangle is what?
Left hand.
Triangle.
Ah, sorry. Half base times right.
Half. Half is this 1.5. Your base. So your height, whichever comes first. Your height, your base. What does it do? So 100 times, okay, times 24.
Yeah, they,
Still,
That's not 24.
no, it's not the same thing. They converted it.
You converted this one straight. This is not how we do it.
it's supposed to be this kind of thing.
So it's supposed to be this and rather than 250. Half base times height, 0.5 times 0.15 times 250 divided by, okay,
No,
divided by
no,
250,
it's still
so
the
you
same
cancel
thing.
times 24. Alright.
It's
So you got 1.8. You understand now?
Yes.
You understand?
Yes, sir.
What did I say?
You said that half base times right.
Yeah, where is the base? Where is the height? Why would you let divide by 250?
Okay, yeah, divide by 2.
See, you're not listening to, you're not why divide by 250. No.
No. But that's not.
Let me. But when you get to design of games, what I'm about to tell you there, I don't want to hear it again.
Okay.
This is a triangle. This is your step. You have it.
Yes.
Every 250.
Yes.
You know why? You are saying yes.
Sir,
I will
no,
give.
the
I have
going
it.
is 215
Did I
now.
call you everything?
Sir, no, the going is. I understand what you're saying. I already know this one.
So you understand where I'm coming. I can give you luck.
So I already
Did I call you
understand.
everything and they tell you God?
I already understand also you're saying, like the going and the. I don't understand.
It's okay. You don't that you don't pass luck too. Like I told them doesn't mean I can't give you luck. But you guys understand.
Yes.
Okay. Let me explain again. In the simple sense that you understand. This is this. Well, I'm teaching you guys just how to estimate the weight. This is this is 250. This is 150.
what is constant? This is constant. This guy. Which is the structural thickness of the staircase. We said it's 150. The self-weight is 0.15 times 24 or 25. We will call this 25 now. So it gives you 3.6. 3.6 what?
Yeah.
3.6 what?
Oh, kilonewton per meter.
What is the kilonewton per meter square? Okay?
These are meter, right?
Yes. Okay, so what is the unit of this line?
Meter.
No.
Eh?
This is the meter. What is the unit of density? Eh? Density. What's the formula for?
And the unit of density.
What's the formula for density? What's the density? This is why I want. What's the density?
What's density? You don't remember in physics?
Are you googling it?
No Google density now.
You know you are connected. I can see what you are.
Density of water. Remember now, density of water.
What is density?
Density is standard.
What's he saying?
You don't remember mass?
And then there's what to do.
There's work to do, Abi.
Density is mass of our body. Abi?
You are
What
saying
is
yes.
Hey.
Then
Okay,
forget
listen.
it.
Yay!
You have to remember your unit and formula. So you know the same thing I said on
It's
unit.
like no, you know. Ṣé bẹ́ẹ̀ ṣe bá wálé ìgbẹ́ sọ?
The physics. It's not easy again, Abi.
No, I don't know.
But I thought you guys had done it already.
Ẹ wá láwọn láìjọ.
What?
Ọ̀gá mi pẹ́ gbé o.
No.
Wọ́n á gbó.
Because you'll be seeing it everywhere.
The only way around it is to be familiar with your unit.
Yeah.
If you know your unit,
What if you're not doing anything that will make you family?
No, you what are you doing now?
what do you,
Yeah, that's.
what do you think you're not doing that will make you familiar with? I mean, there are basic formulas that every other thing is based on.
The same way there's money density. Madam Uche, calculate the unit of slab.
Yeah.
It now go from kilonewton per meter square to kilonewton per meter.
Nǹkan tí mo mú tán.
Wọ́n wá ní how? Ṣé kò answer?
No, nǹkan tí mo mú tán.
Wọ́n wá ní how? Ṣé kò answer?
No.
Ṣé ó answer?
Wọ́n náà sáré fún akẹ́ni
Ó
lọ́wọ́.
padà ok ẹ débẹ̀ ẹ wò bóyá.
And it's very simple to understand.
Mo tún di explain fún ọ.
In column from green to column.
Yeah. Mo tún draw point load bó ṣe di line load bó ṣe di area load.
So, what's the density? What's the formula for density? What is density? I know it's mass over volume, but what do you understand by mass over volume?
The mass of
Okay. This cup. This cup. No, let me use this. Let me use this guy. This guy has a volume. That's what you can take. Now, whatever I put in this jar, the density of what I put in this jar is a function of how much stuff I can stuff into this jar. The volume is constant. If I fill this jar with water, or I fill it with sand, the volume is constant. But what makes them different is the mass of the content that I'm putting in. And how is now different. If I put sand here, I think I don't know if you've seen that analogy before. I put sand here and I fill it up. Okay, if I stretch it, compact it will compact. That compactness is to make it what?
So,
To densify it. The fit test yesterday. What was it? Fit test about? It was density test. If you fill that space, you fill it with sand. You can fill 150 anywhere. Just pour 150 ml thick sand everywhere. Okay? That volume is 150. Okay? When you compact it, it reduces. Yeah? The volume drops because the density has increased. It compacted it. Okay? How dense the material is a function of how compact the constituent of that material is. Which is the reason why concrete, when they say concrete compaction, sand compaction, it's a function of, I'm sure you guys do this in material. You went to the Polytechnic. How are you? University. Yeah, which one? Which one?
On those days when they still
Akuba. Okay, fair enough. Those things because of technology. Yeah. So I'll tell you packing factors of the material. Okay. Now, each material has different packing factor. Packing factor is how much you can put them together and arrange them side by side, their compactness. Now, the reason why you have sand, aggregate, and cement, what's the function of the cement in concrete? To do what?
to bind it.
Concrete is a binding. Concrete is not cement does not determine how your strength of the concrete.
Yes.
It's a binding, it's a binder.
Yes.
Now, what determines the strength of the concrete is how compact is your sand, the mixture of your sand, your aggregate, and your cement. If you have too much aggregate, it's a problem. If you have too much sand, it's a problem. How dense that concrete is the right proportion of the strength of the concrete, proportion of what's it called? The strength of the concrete, how the proportion of the sand, the aggregate, and the cement. Mix them in the right proportion, gives you a certain strength. Alright? So mass over volume, let's assume your mass, what's the unit of the mass? Kg. Volume is what? Why is it meter cube? Because you have length is meter, breadth is meter, height is meter, that what makes it meter cube. Now your mass is kg, your volume is meter cube, your density becomes as simple as that. Now, because we are dealing with, we are talking structural engineering, because of the force. You know, the reason why we take units from kg to newton to kilonewton just to make it reasonable when you are calculating. Imagine we are talking about 3.6 kilonewton and we are talking about it in kg. Talking about it 3,600 kg. It just looks, yeah. So you need to bring it down. So 3 kg, take it to newton, you take it to kilonewton. So the unit weight density of concrete, normal concrete, is lightweight concrete. Normal concrete is 24. In the US code, it was 23.6 to 24. But Euro code says it's 25 now. But if you use 24, you're all well and good. That's why it's 24. Now, if this guy, this nigger, is 24 kilometers per meter cube, and this nigger is meter, what is this nigger? If you multiply meter by kilometer per meter cube, what does it give you? So you have kilometer per meter cube times meter. This comes to, so that's why you have this one is kilometer per meter square. And what does this mean? It means for every 1 meter square, you have 3.6 kilometers being applied. Now, once you see square is an area unit. That means it's applied over
1 meter square. 1 square.
over an area,
Yes.
not over 1 meter square.
Okay.
It's applied over an area. That's what area load means. For example, this guy, this table, that's the gamma that we're talking about when we call the area.
Yes.
If
Yes.
you want to do worst case scenario, you can do within the place of the house. That is worst case scenario. But in reality, you can spread it over the slab. But whichever way you do it, that's like most of it.
Yes.
Right. So that is area load. An area load is applied on slabs, permanently, plates, because you can spread it horizontal. You can apply it horizontally too, because you can apply area load mostly is upper pressure. Because the unit of pressure is what? It's force over area. It's kilonewton per meter. What is the unit of meter?
Sir?
What is the unit of area?
Meter square.
So you can see an area load is also the same thing as you are applying the pressure. Because it's the same unit. So you can apply pressure to this door, you can apply it downward, apply pressure whichever direction. But it's still an area load. So you understand that now. Now, when you now take an area load, because most people take it from density, which is kilonewton per meter cube. Multiply by thickness of the slab that wants to spread. Okay. Then you multiply it. If you want to convert it to line load, what do? Take it down further. Now if you are doing a beam, every time you have to understand perspective. But a beam is a linear member. It's a linear member. The slab is
It's
planar.
Yes.
Planar.
Yes. Not planar.
Eh?
I said more planar.
What do you mean by one plane?
Like that's what I meant.
There is a planar member.
Yes.
Okay. Now, a planar element, whatever it's called. Your beam and your columns are linear.
Yes.
But there's one between your beam and your column, which is what I was trying to explain to you. I was learning, but I just like, because I know we'll come to it. They have already told me about it. You don't know this thing. Yes. You need to go and check something. So, now, if you apply an area load on your slab, and your slab is supported by a beam, it doesn't become a ladder.
It goes.
You apply an area load on your slab,
Yes.
which is kilonewton per meter square. That slab is supported by a beam. What does that slab load becomes when it gets to landing?
What does that slab do?
Yeah, the slab is an area load,
Yes. Yes.
and that slab is supported by a beam.
Yes.
The slab load is an area load. When it gets to the beam that is carrying it, what does that load becomes? No, it's already an area load. Am I giving you guys
It
points?
becomes you measure
How many loads do I
a
have?
line point load.
How will it become a point?
Because it's acting on one like
What did I call it? What did I call it slab?
it's more plain.
Plane. How do you
So you
know
don't make it more plain, more plain.
It's
It's
a
a
planar-
plain.
planar member.
Yes.
A beam is what?
It's linear.
Linear. So if you have an area load coming on top of a linear member, it becomes a line load.
Yes.
We are saying yes. If you are saying yes, if you know you would have said yes. Do you guys understand?
Calculate this.
We are not even explaining the staircase I want to explain.
Sir, there is nothing in the book. Sir, there is nothing in the book.
You have a slab. The ELI represents what? Let's the system has one way. But you have area load of 3.6 kilometers per meter square. Apply to over this land. Okay? You put 360 kg. Or 0.50, 0.5. 0.5 anything is what? It's equivalent to 50 kg. Cement. Bag of cement. Let's say we put 50 kg bag of cement over this land. Okay? 3 meter square. Now, this beam. So this lab is taking 0.5 kg per meter square. So this beam, which is one way, this is the shortest. So what that means is that let's say this beam is 5 meters. That means this beam will carry half of this load, and this lab will carry half of this load. One way. That's what it means.
So the beam will carry out.
This beam will carry half, this one will carry half. This one's will not get, before they get any, because of the shortness of the span, this one will already take in the stress before they even get it. Because it will transmit faster to this one before it gets to this one. Because of the shortness of the span. But if it's two-way, sorry, I'll show it. If you're doing it line, sorry. Take this triangle, this triangle, this trapezium, this trapezium. So you need to estimate the area of this trapezium multiplied by the weight to tell you the line load of this guy. So the area of this trapezium multiplied by 0.5, because half that percentage of 0.5 will go to this guy. So that guy will take this percentage based on this guy. This guy will take this percentage, this guy will take this percentage. That's it, it's two-way. So this is one way, and you are not doing management analysis. So this will take half. Assume this will take half. That's the worst case scenario. This guy will take half. So half of 5 is what?
2.5.
This is 2.5. This is 2.5. Again, meter. So what you do is, since you are dividing into 5, into 2, 0.5 kilonewton per meter square times 2.5 meters. Half is going, half is going there. That gives you what? What? How is it cube?
This one is.
This one is meter. This one is meter square.
Oh, meter.
So meter is what now? Is it clearly the line? Because it's every 1 meter. So the area now becomes the line load of the beam. So this 1.5 becomes 1.25 on this guy. Is it 1.25? Am I correct?
Yes.
So because 1.25 this guy. So 1.25 kilometers per meter. If you want to convert it back to line load, to area load rather, what do? You divide this by 2.5. No, you multiply it. No, you don't multiply. No, you divide by 2.5. If you want to convert it back to area load, you divide by 2.5.
Yeah.
Size multiply.
2.5 times 1.5.
3.25.
So what have you just done?
Huh?
What have you just done? By coincidence, you've done something. It's not like you are correct.
Yes.
Based on what we are discussing, you are very wrong. But by coincidence, you've done something. What did you do? What has she done? No, you're not working with this. You already have 1.25 kilometers per meter. You multiply it by meter again. So what are you doing?
That's impact on this. You're taking away.
So you are converting it to what?
Ah, please, no. I don't understand what you are saying.
Yeah, I think you have work to do. We have work to do. Work to do. 125 kilometers per hour,
Mm.
which is a line, which is a line load.
You know, it's like-
And now, but you now decide to, you are wrong, you are still wrong.
Wait, oh.
You now decide to multiply it by
By 2.5.
Convert
I
this
thought
back
it's
to
kilometers.
area load.
Yeah.
This
This
now
there.
multiply by 225.
Yeah.
Which is wrong.
Which is wrong
And
now.
now then you are wrong.
Okay.
You achieve something by mistake. What have you
I
done?
thought it's kilometers.
And what is that?
The
What kind of load is it?
what
What kind of load is in kilometers?
points load?
You know you are wrong when you
Yes.
by mistake now you learn this. So assuming this beam span, you know we've taken this area load to 125, the line load of this beam. So assuming this beam span is 10 meters. So what is this? Convert this line load to a point load on this beam.
You said, assuming this is 10,
Yeah, assuming this span is 10 meters. And this is our line load acting on this beam. Convert this line load as a point load on this beam.
okay, we should convert this line load to a
This is your line load.
Hmm.
And we are converted to be a point load on the beam.
You can draw it first to see what it's going to look like. A beam with point load looks like how?
Sketch.
Like this.
Draw your beam. Yes. So convert. You have a line load. You have to be looking at unit if you are converting.
So now,
Yes. UTL. Convert that into point load. Per meter.
we have this line to be 10.
Yeah, convert it to
10
point
or
load.
10.
Eh?
Convert it to point load.
Yes, yes.
You guys pick up.
That's the techniques of economic, you know, structural techniques.
Point of concentration in Masala.
So
You have to go through it.
12.5
Eh?
What did you say? Say it loud with your chest.
And then
Say it now, except you are not sure.
12.5.
Are you sure? Are you sure?
So you are correct.
It's just unit. The idea is unit always.
It's just 1 times 1, 2 times 2. Most of the things that you'll be doing has to do with this unit. And if you don't know how to take this unit from one form to another form, there is a problem. Are you guys clear? Or should I go right away? You are very clear.
Yes.
Or I should go right away? I'm not going to do this again with you guys. I should start from density. See, I've told you, I'm not going to go back to it again. So if you want me to take it now, again,
I have a question. So, if you don't go right again now,
Yeah.
so if you want to,
come in. Till tomorrow. What up?
so if we want to apply this now, if you want to give us like an exercise, like an assignment or something. In what
You
area?
know, beside, this is not after what we're talking about. See my problem now. Most times, what you're actually supposed to be talking about, you would leave it and I'll be talking about it. It's not those two guys, it's every. But I just need guys because I'm not going to go back to it because we need to focus on this guy. And if you guys have issues with the basics, let's trash it now. So this is basic. Auntie, Sarah,
Sir?
are you good?
Yes, sir.
Very good.
Yes.
Any answer they can mention it. This to yes. The second.
Yes.
You get the top one.
Mm.
You want to change your mind, so that way you can go for another.
Oh, yeah. So let's go back to this attachment that we're talking about. So now you understand what 1.5 times 24, I mean?
Yes.
Okay. Are you still interested?
Yes, yes.
Okay. And this thing is, by the time you are used to it, just come to you naturally. Of course, there will be situations where simple sign can grab both of us. We'll act like you guys too.
You believe that?
You understand?
I've been doing like this all my life.
If you grab both of us now, was it 2 nights ago that you called us out of the blue?
Yeah, not sleep.
And they couldn't see anything on the phone. There are levels to this thing. Let me enjoy my own edge. Well, it will be very, very bad if he's not the one explaining this to you guys.
Yes, yes. What's
You understand? So, the waist is the structural thickness of the staircase. That's actually what it's designed for.
Yes.
Designed for the waist of the staircase. No. And this, whatever, our waist is 150.
Yes.
Don't say yes, you don't understand.
Yes, I understand that part.
Now, we are, so we're going to take the weight of this waist. Like any Nasobic said, when you are designing this staircase, you assume this slab. The thickness of the waist is 150. The circuit of that waist is what? 0.15 times 24. That's how they come over that 3.6 that he has there. Now, finishes, we assume, and I told you never to assume finishes.
I did not assume finishing.
I'm not saying assume. So what do you do?
I used to make myself go.
How do you run?
I did think of the.
To explain finishes to her.
I think it was the tiles.
Explain finishes to her.
Okay, finishes is how would I do it? Is it things that like the dead load on the slab, on the finish slab. Like the dead load on the house now, the screening and yes, and the pipe, the space left on the pipes. So I did 60, 30, something. I was done on them by 24.
Okay. So let me explain to you and then to you. I'm not saying you're not correct. Let me explain it. That is the map. It's 150 thick. Concrete, you can see to the sides. But in reality, we're still going to put finishes to that. The build up for the floor finishes, which is a delicate is permanent, is the screed, the tiles. Come back to that side. Let's just stick to these two things. The screed and then tiles. Now I'm doing a design. And the architect has his finishes over the slab at 70 mm. There are some areas that has it at 250 mm. So you need to know what your architect is thinking. That's why I said we cannot follow what's in the book. What is like one point that has assumed, if you take the density that has assumed 50 mm finishes with the tiles thickness. Now, if we assume 24 as the density of the screed, assumption, and use 1.2, and your architect, like my architect, has said to use 100 mm thick screed, you know the problem.
Yes.
That means you underestimated your loading for finishing by 100%. That's why I told you, we are reiterating on it. Don't follow the book. There are situations where the architect does not know. You really want to tell him. Because most architects will not even consider, they won't even talk about finishes. It's not that they're using Revit, that they're adding finishes. Most of them, they won't talk about it. They won't even talk about scripting in a section. Those that use AutoCAD, they don't put we just write it in. So you need to know what the thickness of your final finish level is. Now, one of the things that you consider is that
if you are putting pipes inside the screen, electrical pipes, one pipe is what? 2 thick. Diameter. And the area where they will be overlapping. So that is very small. So you cannot use minimum, you cannot use less than minimum of 15. But there are situations where you have more thickness of pipe, which is why you need to coordinate with your mechanical guys, your electrical guys and your architect. Right. So that's about the finishes. But for this case of the staircase, it's like you said, it's screened and thread. But you need to understand that staircase is finished on, the slab is finished on just one side, the top. If you have a ceiling, nobody cares what is under. If you have a ceiling, if you don't have a ceiling, you plaster the other side, which you don't consider upstairs, you just consider the other top. So if there is no ceiling, you need to consider the boot of the plaster on the underside of the slab. Now, what this guy has done now is that they have not considered that they are going to plaster here the waist of it. So, if you are using scale will ask you for finishes at the top and finishes at the bottom. So, what this man has done is that, which is not good to follow, is good. The book is good, but you don't follow it in practical life, real life situation. You have to apply. Follow this, and you apply experience. That's the difference between you and an undergraduate. You guys understand?
Yes.
You guys, that's why I told you that you have to stop thinking like a student. You have to start to think like an engineer. Apply life situation. So, if you have done this in your book, in school, you'll get A. But if you do this in reality, the design is not okay. The slab might, the staircase might stand, but if you put torchlight to it, you pick up the issues. So now, if you want to now consider the one finishes, consider the one on top and the one on top. So, and in reality, your script is not as tense as your concrete. Concrete density is 24. Your screed is not as dense. So most times we use 20 for the density of your screed, and your tiles too is not as dense as your screed. So that's why we use 20. So we use 18. Okay?
Yes, sir.
Alright. So now let's go back to area of the triangle. So now that we determine the weight of this post, we determine the weight of these guys. Now, the guy has done one gymnastics that you guys are not going to understand. For now, it's like kingdom come, which is this guy. Now, by face value, this guy is half base times height, area of this triangle. Of this triangle. One of them. No, I have how many? 1, 2, 3, 4, 5, 6. I have 6 of them. One of them is 4.5 half times. Yep. Are you guys home? Are you guys home? No? Alright. I didn't hear from you. How is she? Alright. So, So our base is 250. Our height is 150. What's the touch? What's the touch?
18,750.
How now?
So I said out base like that. The base is 250 and the height is 150.
So that's 18 point.
So I'll look at it.
The meters.
What is it? Yeah, what is the thing number? Yeah, what is the units again? What is the units behind it?
Meters.
What is this one?
Meters.
What is this 50? Is it meter or millimeter? What is this 150? So why are you giving me millimeter? When I'm working in meters.
I don't want to jump.
So you think that's the answer?
No. But, so I just look at it. Let me please.
Is 18.75
As a lead king, as a You pick 250, which is millimeter, which is to convert to 1 meter. To convert to 1 meter, listen, you don't know what you're doing. This is the answer, but you don't know what
Sir, I already understand
What
what
do
you
you do?
mean.
Are you following? Because both of you are the same thing.
Okay, you convert this one.
I
first.
converted all of them onto meter.
So when you divide it by 1,000, what did you do?
I divided by 1,000
Why?
to convert it back to meter.
So why is the answer different from what you're showing? You gave me 18.2.
Yes.
So why did you get in 0.6175? You did 250 times 150 times 0.5.
Yes. Yes.
And it gives you 18,750.
Yes.
And I said you want to convert it back to meter. Divide by 1,000. What did they give you? 18.75. So when you now do this separately, and it's not giving you 0.081, is it the same thing?
No.
So what did you do?
We didn't convert it first. We're supposed to convert it first.
No. That's not what I'm trying to do. When you divide it by 1,000 the first time,
Okay, you're supposed to be 1,000 in two places. That's 10,000.
Oh, yes.
so what did you do? So the area of the triangle is 0.01875
Yes.
meter square. Alright, so now the density of this guy is what? This step is what?
And should we use 20?
What's the density? Is it not concrete?
Yes, 24.
So 0.00175 times 24 is what?
0.45.
So you know what 0.45 is? What is this?
Okay, that's
How will you answer?
90
So what is it supposed to be?
I said it before you. I said 20,000.
Yeah, like I said.
Yeah.
Around that. Now, does this align with my 3.6? Can I have this please? Why not?
No, I can't have this.
Because this one is different SI units.
So the units is different.
Yes.
Okay. So what do I do to make this guy same unit as this guy? Because I'm doing slab, so my unit is here is going to have another square. So what do I do to make this guy? What do I do to connect this guy out to this guy? Mind you, I've only estimated for the weight of one of these. And I have how many? 1, 2, 3, 4, 5, 6.
Maybe you are ready to finish.
Yeah, so what do you do? What has it done? What did it do? Can you reason for what Dr. Emela?
Only reason trees.
And you couldn't, don't understand.
Yes.
When did you go and start something? What was the weight? What's the one of Eliza?
150.
Eliza.
Yes, Riker is 150. The thread is 250. Oh, it looks like it's not Riker is 175.
Can you go up? Can you go? Go down.
This 175 again. Oh. It's 150.
Where? Where did you
So I go to say use.
Where? Let's see it.
Okay, we were checking the other one. We were checking this one. We were checking this one. This one was 175.
There's
For
one second.
open staircase, yes. Why
Go
they?
back, go back. Go, slow it down. Go down.
Ah, sorry.
So it's open well that is doing.
Yes.
So the rise is 2.75.
Yes.
And the stop is what? 275. So we don't know calculation. So this is 270. Okay.
No, no. Sir, we are doing for half staircase.
Oh,
For
we're
us,
following what we told.
And this was we were following before. This was we were following before.
So are we correct?
Yes. And he used
Okay.
0.05.
Okay. Alright. So we are correct. So let's go back to what we were talking about. So can you guys listen, based on what I've said, can you guys listen to how he has done his German? We have these steps, and at every 2 to 15, 2 to 15 meters.
Yes.
So you have to divide this value that you get, it's a meter per meter. You have to divide by 0.25 because these guys are every 2 to 15 meters. So that's how we did 0.5 half, 1.5 because the 250, we cancel 250. Maybe we've done it together. This is what I'm saying. I think we said half base times height over 1 times 24.
Yes.
That's 0.5 times 0.15 times 250 over 250 times 24. This will cancel this. That's why it has. You understand?
Yes.
So, you guys take the rest of it. I've tried to do that.
Is there any other one that is confusing? I mean, you know the line, I've explained the finishes now.
Yes.
You know the line finish. I know what this two factor does.
No, I don't know.
You know what it does? Because the weight of a slab, when it's straight and when it's inclined, it's not the same. So you need to use this two factor to bring it back
So the normal level.
to normal level, so you can design the slab. Okay, so what, as against taking the entire staircase, he used a step. Same thing, 250 plus 150. Pythagoras theorem, divided by 50, gives you the factor of 1.16. So whatever you're doing, you have to multiply it. Whatever load you get, multiply by this factor to bring it to. So go down. So you can see 3.6. Okay, all walls are 2.5. 3.6 plus 1.2 finishes times 1.16 plus 1.8. Okay, so is this slab, the structural slab, which is the waste. You can see that they didn't apply it on the step.
Yes.
It's already sorted out the steps.
Yes.
Because you counted them one by one. So you only apply the split factor to the finishes and the thickness of the structural waste. And then plus 1.8 pixels or steps. Times what?
1.2.
What's 1.4? What's 1.4?
Dead loads.
Factor 6.
Factors.
Plus 1.5. Live load.
Live load.
Times 1.6. But if you are designing staircase according to code, you only see 1.5 as live load.
2.
Is it 2? It ranges.
I saw 2 somewhere.
I think it ranges from 2 to 4 something, depending on the function of the area that the staircase is serving. I think it's minimum in the local is 3. Right? So, you know why they use 3?
No.
For emergency.
Okay.
Alright. Emergency don't use lift, use staircase. People wash down the staircase. You have to design for it. That's why they use 3. Times 1.6 is what? Laptop 6 for that. So this is how you get this book. Then it continues. I'm showing you guys that finish. Praise the Lord. Let me return my mama back into bed. We'll continue next. Eh? Get ready. Professor, you know.
I'm doing this. I'm going to get them.
What will you do this guys?
Just
5 minutes.
sleep. Thank you. I'm supposed to meet somebody. I'm still going to hear about it. I want to meet someone outside. Yes.
Is it in the same direction as
Hail flutes rising up in a waterfall of dripping ocean.
Same direction.
Magnificent.
I feel bad. Jesus, so doing like this.
Actually, so let me know. Then, allow me to solve more about that.
Thank you guys. Okay, yeah.
How many people view this?
Me too, except I end it. That's when I'll know the total number.
Please tell me their time.
You forget about the unit. You guys should just keep on, you will see. It's a matter of time. Good night.
But me, I will still use you.
You won't
You
send
cannot collect knowledge for free.
So I don't send the code.
I will send it to you later. Remind me again.
Like you will not reply my message.
I will reply again. I mean, I was I'm thinking whether I should continue.
Alright, sir.
Okay.
I'm driving. I'm not concentrating on driving.
So they come and pray. I need to not sọ̀rọ̀ lórí. Mo ní ẹ̀sà, ẹ̀sùn ìṣe yàtọ̀ sí ọmọ. Díẹ̀ náà ló lè tọ́. Ẹ máa ṣàánú. Yes, now. Even àwọn tó dàgbà wọ́n sì sọ pé wọ́n yé kọ́ ní ti. Ẹgbẹ́ jẹ́ pé kò ní fàyà.
So you have fixed the.
Okay. This?